Okay, so guys, I realized too late that the 12.7 video that was connected did not really line up with the assignment as well as I would have preferred. So I promised somebody today that I would record a video going through those examples, and so here I am. So I apologize for the quality of this. The printer and I have been at odds, but we're good now. Okay, so this one is going to correspond with the question on number 1 on your homework. So the graph below gives the birth weights of a population of 100 babies. The red curve, which you can't really see, shows the weights are normally distributed about the mean, 3,250. So the mean would be right here. Estimate the percent of babies weighing between 2,500, so that's here, and 3,999. 3,099 is here. So that's going to be these bar graphs right here, or these bars. So we are looking at this number, which is approximately, this would be 25, so maybe 24. And then this one looks like maybe it's a little bit less than that, so maybe 23. And then this goes past 40, but it doesn't look like it's quite halfway between 40 and 45, so I would go with 42. So I've got 24 plus 42 plus 23. And then that is going to give me 4 plus 2 is 6, plus 3 is 9, 2 plus 4 is 6, plus 2 is 8. So that gives me 89%. Now, if you look down here, the textbook author suggested that was 23 and this is 23. So it's really subjective. It's up to what you see. And there is going to be a little bit of flexibility with respect to an answer like that. Okay, so it's just reviewing how to read the bar graphs. All right, now looking at a normal curve and whole. Before we do this, I want to visit this image. All right, so the standard normal curve allows us to have, I'm going to pause this real quick. I wanted to make sure I had a marker that worked. Okay, so within one standard deviation, this is one above and one below. This is 34 and this is 34, and this would give me 68%. Okay, between two deviations, so 2 below and 2 above, this is going to give me, let's go here, and that's going to give me 95%. Okay, so 95% minus the 68 is going to give me 27. And then 27 divided into 2, because we have this, we have both of these pieces. So 27 divided by 2 is 13.5. And that's where they get this 13.5 from. And I just wanted to make it a little bit darker because I couldn't tell. It doesn't look like it's showing up very well. All right, and then for 3 standard deviations, right, that is going to give us 98%. Okay, and so the difference between 98 and 95 is just 3%, and then 3 divided by 2 is 1.5. So we have 1.5 here, and we have 1.5 here. Now, that's just 98%. So, hang on just a second. Okay, sorry about that. So this is just 98%. So there's another 2%. So the 2% is outside of the three deviations. So if we had 100 minus 98 is 2, and then 2 divided by 2 is 1. So then you have 1% here, and you have 1%, on this side. So it's outside of those 3 standard deviations. Okay, so the numbers that you have to remember are going to be 68, 95, and 98. 68, 95, and 98. Remember those, 65, 95, 98. When you draw the normal distribution curve, and it doesn't have to be pretty, your mean always goes smack dab in the middle. Okay, one deviation below and above is going to give us the 68%. So this is 68%. 34 and 34. Two deviations, so two above, two below, that is going to give us the 95%. And then that gives us 13.5 and these pieces. And then three deviations is going to give you 98%, which means you have 1.5 here and you have 1.5 here, which means above, outside of the three deviations, it is 1% on each side. Okay, so now with all of that, let's take a look at example 2. So it says a survey of the employees of XYZ Corporation found that the meaning of the morning commute times to work was 18 minutes. The standard deviation was 4 minutes. Sketch a normal curve showing the commute times at 1, 2, and 3 standard deviations from the mean. Okay, so my mean is 18. My standard deviation is 4. Okay, so I'm going to sketch a normal curve. Here is my mean. And I guess I could put that above. I'm going to put that above. So my mean is there. This is 1 standard deviation above. This is 2 standard deviations above. And then this is 3 standard deviations above. 1 below, 2 below, and 3 below. All right, now the numbers that correspond with that. So my mean is 18, so I'm going to have 18 down here. And then to get 1 standard deviation above, I'm adding the standard deviation. So 18 plus 4 is going to give me 22. To get to the next one, I add 4 again. 22 plus 4 is 26. And then 26 plus 4 is 30. So now I have the deviations above. Now let's do the deviations below. 18 minus 4 is 14. 14 minus 4 is 10. And 10 minus 4 is 6. And this is what you are supposed to draw. This is going to correspond with numbers 2, 3, 4, and 5 from your homework. Okay. Now looking at 6 through 8, it is going to go with this part A here. And then 9, 10, 11 is going to go with this part here. All right, so in a survey, the responses to the questions, how much time do you spend in the shower every day? These were normally distributed. So that tells you you have that normal curve, okay? The mean was 15 minutes. And the standard deviation is 2 minutes. Okay, so now it says what values are 1 deviation from the mean? Okay, so we would take our mean and we are going to add and subtract our standard deviation. And this is just 1, so it would be 2 times 1. All right, so you've got 15 plus 2, and you have 15 minus 2. So that's going to give you 17 and 13. And you can do it this way. So like if I were to find the values that are 2 standard deviations from the mean, then that would be my mean, which is 15, plus 2 times my standard deviation, which in this case is 2, and 15 minus 2 times the standard deviation, which is 2. So 15 plus 4 is 19, 15 minus 4 is 11. So this would be for 2 standard deviations, and this is for 1. All right, now you can also draw the curve and do that graphically, do that using the image. So here's 15, you add on 1 deviation. So you add the 2, that's 17. You subtract the 2, that gives you 13. So that would be between 13 and 17%. Okay. Part B. What percent of the responses would you expect to find that are less than 13 but greater than 17? Okay, so I personally need to draw a picture when I do this. Now, I know that this answer is over here, kind of, sort of, to some extent. Let's say we have just to find what percent of the responses would you expect to find that are greater than 17? Okay, so I'm going to go ahead and draw a normal distribution curve. And I like to sketch this out so I know what am I looking at. So I'm looking for greater than 17. My mean is 15. And then my deviation is 2. So I'm looking for 17. 17 is more than 15, so I have to add 2. This was just one standard deviation away. Okay, now going back to this normal curve, right? Sorry. Going back to this, the 68, 95, 98, I know that on this side of the mean, it's 50%. On this side of the mean, it's 50%. But then within each of these pieces, there are the 34, 13.5, and then the 1.5s. Okay, so now looking over here, I'm looking for greater than 17. So I want this part here. Well, I know this is going to be 50% because that's on the lower half. And then in this first part, that is just going to be the 34%. So now I add these two together, and that's going to give me 84%. But that's the unshaded part. I want the shaded part. So then I do 100 minus 84, and that's going to give me 16%. Now, if you remember these numbers, you could, if you memorize these numbers, you could then just add these numbers together, 13.5 plus 1.5 plus 1, and that's going to also give you the 16%. So it's really up to you as to which method you want to use. Okay, I said 9 through 11. Okay, so then 12 through 14 is going to go with this one. Use the distribution to answer the following questions. Assume there are 92 students in the lecture class. I think that's what it's going to go with. I'm going to press pause for a second. Okay, so I paused to check something. I said these are like 9 through 11, and they are, but they are more like 12 through 14 with this wording than they are 9 through 11. But 9 through 13 is basically, or 9 through 14 is basically all the same thing. It's just the wording is a little bit different. So rather than move on to the example that corresponds with 15, I went ahead and printed this out so that I can do an example with you. Now I'm going to refocus this, so I apologize for the blurriness. Looking at number 9. The number of cookies in a shipment of bags are normally distributed. So we know we have a normal curve. So that's the 68, 95, 98. With a mean of 64 and a standard deviation of 4. What percent of bags of the cookies will contain between 60 and 68? So I'm going to go ahead and sketch a normal curve. This is 64. My standard deviation is 4, so I'm going to add one of the 4s, that's going to give me 68, and I'm going to subtract 4, which is going to give me 60. And then I come over here and I look, and lo and behold, that's exactly what I needed, between 60 and 68. Now, going back to this piece here, we know that one standard deviation out is going to give me 68%. So this is one deviation, this is 34, this is 34, that gives me 68%. And that's it. That's all you're doing. Okay, so now let's take a look at this example, which corresponds with number 15. Use the distribution to answer the following questions. Assume there are 92 students in the lecture class. The professor has found that students who score between 1 and 2 standard deviations below the mean need to attend study sessions in order to pass the class. So between 1 and 2 standard deviations. All right. So if I'm looking at my curve, here's 1, here is 2. Okay, I know that here is 34, here is 13.5, and it just says between 1 and 2. So that's going to be between here. So 13.5% of the students, and in this case there's 92, need to attend the study sessions. So in math, when we have a percentage, we convert it to a decimal, and then of means to multiply, and then we've got 92. So then we've got 0.135 times 92, and that's going to give me 12.4. All right, we cannot have 0.4 of a person. It doesn't matter how tall or how small, if they have all of their limbs or not, they are still a person. So we are going to go ahead and round up because we can't have half a person, right? So we're going to go ahead and round up. So we're going to say there should be about 13 people who need to attend the study session. That's it. All right, and so this is what you're doing with Betty's bite-sized cookies, that problem. So you've got to find, I think for that one you have to find the how many deviations it is first, and then I can't remember exactly 100%, but this is going to go with number 15. All right, I hope that helps. I do apologize for the circumstances. This is not typical, and believe it or not, this is going to actually benefit you, and it's going to make you stronger in the long run. So I believe in you. If you need me, make sure you email me and or let me know that you need to come see me during advisory or before school. All right, I will see you later.